All right, welcome to lesson 4.1.2, determining the better measure of center and spread, day 1. So we start off with our vocabulary words. As you can see, they are already filled out, but I will read it to you. So the first vocabulary word is statistics. Statistics is the practice of collecting and analyzing numerical data. So if you haven't realized, we're doing statistics. The second definition is measure of central tendency. Measure of central tendency is a single value that attempts to describe a set of data. A single value that attempts to describe a set of data. So that's going to be like something like mean or median, some things that we've covered before. Our third vocabulary word is interquartile range, also known as the IQR, standing for interquartile range, so IQR. It is a measure of spread, so it helps describe how spread out your data is. So the formula for the IQR is Q3 minus Q1. Do you remember Q3 and Q1 from the 5-number summary? Those are the Q3 and Q1 from the 5-number summary, two of the numbers that we use in the box and whisker plot. All right, next vocabulary word is data distribution. Data distribution is, or they are graphical methods of organizing or displaying info, also known as the dot plot that we've done, the histogram, the box and whisker plot. Those are data distributions. Next vocabulary word is outlier. An outlier is a data point far away from the main chunk of data. So if your data is like 10, 10, 10, 10, 9, 8, 7, 10, 10, 8, and then you have 300 as part of your data. 300 is an outlier because it's far away from most of your data points. Most of your data is around 10 and 9 and 8 and 7. And then you suddenly have a 300, that 300 is an outlier. And so when we're calculating outliers, we're going to calculate something called the lower fence and the upper fence, our last two vocabulary words. So for the lower fence, that separates small outliers from the main chunk of data. The upper fence separates large outliers from the main chunk of data. But the lower fence and the upper fence, they just section off the main chunk of data, and then anything outside of the lower and upper fence, those are going to be your outliers. And we will learn how to calculate your lower fence and the upper fence as well. Actually, you know what? I'm going to put in their formulas right now. So the lower fence formula will be equal to Q1 minus 1.5 times the IQR. Remember, the IQR is the interquartile range. And then your upper fence formula is Q3 plus 1.5 times the IQR. So remember, in your box and whisker plot, we have Q3. I'm just going to draw a box and whisker plot here. So your IQR is Q3 minus Q1. So it literally tells you how spread apart this section is. So your Q1 and Q3 make up the box of your box and whisker plot. So this purple section, when you subtract the Q3 minus the Q1, that will give you the IQR. And then after that, you're going to take the width of that IQR, like how wide it is. You're going to multiply it by 1.5. So you can see that IQR gets multiplied by 1.5 in both of these equations. And then for the Q1, you're going to do, for the lower fence, you're going to do Q1 minus the 1.5 times the IQR. So that means you're just going to take this part, and that's about, here's your Q1, and you're going to subtract off 1.5 times the IQR. And then however far that goes out, this is your lower fence. So then this point would be an outlier. And for your upper fence, let's just say it's Q3 plus 1.5 times IQR. This is your Q3. So you're just going to add 1.5 times the IQR to this. And then it's going to be here. That's your upper fence. And then, oh, look, there's nothing outside of it. Then there's no outliers. So that's just a quick example. but we're going to do the actual calculations later on. But this was hopefully a slight visual to show you that the lower fence and the upper fence kind of show you where the outliers are. So this one would be an outlier simply because it's outside of your fences. Okay? All right. Now moving on from the definitions, let's go on to 3 common distributions. We've kind of talked about this already before. We have skewed right and skewed left, as shown on, I can't point. As shown over here and here, we have skewed right and skewed left, which we have covered already. And in the middle is a new type of distribution called symmetric. So symmetric is where it looks kind of like a mirror image on the left and right side. The mean and median are equal when the data are symmetric. That's what it says right here. So the data is symmetric when the mean and median are equal. When it's skewed right, take a look over here, the mean is greater than the median. Look, most of the data is to the left. Most of it's on this side. Most of your data is on the left. So these data points over here, they're going to skew your mean to the right side. So your mean would have wanted to be right underneath the median. However, those small data points that are over here, they pulled the mean to the right. So this is why it is skewed right. So the mean is greater than the median when the data is skewed right, and the median is the best center of measure because the median is not affected by large data values. So when you're talking about the best measure of center, we're going to be looking at the median whenever it's skewed. Take a look at skewed left, which is on this side. So very similar, we have most of the data on the right side, so therefore the mean gets skewed to the left because of these small values. And so when you have a skewed left, the mean is less than the median when the data is skewed left. The median is the best measure of center because the median is not affected by small data values. So very similar to skewed right, where the median is the best center of measure. So anytime your data is skewed, the median is better than the mean. All right. So let's go on to part A. We're going to create a dot plot of each given data set. We're going to calculate the mean and the median, determine which measure of center best describes the data set. All right, so let's start off with a dot plot. So we have 6, 7, 5, 7, 8, 4, 7, 9, 6, 8, 10, 7, 6, 7, 8, 7. Okay. So now let's calculate our mean. So in order to calculate your mean, you're going to add up all the numbers and divide by how many numbers there are. So let's add it all up. We have 6 plus 7 plus 5 plus 7. Like literally, I'm just writing out all of these numbers. So let me write that out while I pause the video, and then you can see me when I'm done writing all the numbers. Okay, so as you can see, I wrote out all the numbers, and now I'm gonna have to see how many numbers are there. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 numbers. So I'm gonna add it all up and divide by 16. So once you add it all up and you divide by 16, you're gonna get this number, 7. So obviously, please do this on a calculator. You add everything up, you divide by 16, and you get 7. When you are typing this on a calculator, I recommend you put this in parentheses so that everything gets added up before you divide everything, the entire sum, by 16. Otherwise, you'll get something wrong. Okay, so this is our mean. For the median, let's calculate the median. So luckily for us, when you're calculating the median and you're given the dot plot, you don't have to order everything from smallest to biggest because technically your dots are on the number line already. They are by nature on the number line already ordered. So you can cross out these dots as if they were the data points themselves because every single dot represents a data point. So to calculate the median, I'm going to cross them off one by one. So I'm getting rid of the edge pieces. And then I can see there's two numbers here in the middle. So each of those two numbers represents a 7. So we have 7 plus 7. Oh, how do I know they represent a 7? Because they're on top of the 7. So 7 plus 7, and then you divide by 2 equals 7. So therefore, my median is 7. So as you can see, the mean and the median are equal. What happens when the mean and median are equal? The data is symmetric when the mean and median are equal. So when the mean and median are equal, the best measure of center will be the mean. I mean, it really doesn't matter because the mean and the median are exactly the same, but for our purposes, please say that the mean is the better measure of center. And I'm going to say because symmetric. How do you spell symmetric? I spelled that wrong. Symmetric shape. So when it's a symmetric shape, you want the mean. Okay. So let's try number 2 together. So we're going to create a dot plot. So let's do that. We have 12, 22, 11, 13, 12, 22, 17, 12, 15, 22, 11, and 12. Okay, so we got some weird shape going on over here. So let's calculate our mean. So remember, to calculate the mean, you want to add up all those numbers. So starting with the 12 plus 22 plus 11 plus 13 plus 12. That looks like a 72. Plus 12 plus 22 plus 17 plus 12 plus 15 plus 22 plus 11 plus 12. So all of that divided by how many numbers are there? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers. So I'm going to add it up, divide by 12. By the way, another way that you can calculate mean, it's the same thing. It's just by looking at the dot plot, because now the dot plot has helped us organize it. So you can see that there's two numbers in 11. So I can say 2 times 11 plus, there's 4 numbers in 12. So I'm going to say 4 times 12 plus, there's one number in 13. So I can just say plus 13. And then plus 15 and plus 17 because there's only one number in those. And over here, there's 3 22. So I can say plus 3 times 22. And then you still divide by the total number of dots, which is 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12. So it's still 12 dots. But either way, both of these should help you calculate the mean. They're both equally valid ways. So do whichever one is easier to you and makes more sense to you. So once you calculate this, both of these will be equal. They're both equal to 15.083 repeating. So I'm just going to write 15.083, round it to the nearest thousandth. That's okay. So once again, both of these come out to 15.083. Okay, now let's calculate our median. So from our dot plot, we can start crossing off numbers. All right, so now we have two numbers in the middle. We have a 12 and a 13. So I have 12 plus 13 divided by 2, and it gives me 12.5. All right, so as you can see, the mean and the median are not equal. So let's see, is this going to be skewed left or skewed right? So we want to see our mean is greater than our median. Let me highlight. The mean is greater than the median. So therefore, we have skewed right. So I highlighted over here, skewed right because the mean is greater than the median. So I'm going to say that the median, oh, let me write that out. Okay. Median because skewed right. So most of the data is on the left side. This is like a higher pile than this one. So that means these data points are skewing our mean to the right side. So whenever you have a skewed graph, skewed left or right, the median is going to be the better measure of center. So the best measure of center here is the median because the shape is skewed right. So if you have any questions, please call me over, let me know.